Python Tkinter tutorial, building graphical user interfaces. Welcome to the Tkinter tutorial. Tkinter is Python's standard library for creating graphical user interface (GUI) applications. It's built in, meaning you don't need to install anything extra. It comes with your Python installation. In this lesson, we will explore the core components of Tkinter step by step, and build 10 practical examples to help you understand how to create your own GUI applications. General Tkinter principles: import. Always start with import Tkinter as TK, the alias TK is commonly used for convenience. Root window, this is the foundation of your application. You create it using TK. Widgets, these are the building blocks of your GUI, buttons, labels, input fields, etc. You create them by passing the root window, or another container, as their parent. Layout managers, you define how widgets are arranged within the window. The most popular ones are packs widgets into blocks, positioning them automatically. Easy to use. Grid places widgets in a grid, rows and columns. Excellent for complex forms. Place positions widgets at exact x, y coordinates. Provides the most control but is harder to manage for responsive designs. Event loop, this is the heart of your GUI. Root.main loop starts a loop that continuously listens for events, mouse clicks, key presses, window resizing, and updates the interface. Without it, your window won't appear. Examples. Example 1, creating a simple window. Let's start with the simplest task, creating an empty window. Step 1, create the main window. Step 2, set the window title. Step 3, set the window size, width x height. Step 4, start the main event loop. This allows the window to be displayed and respond to user actions. Step-by-step description. Import Tkinter as TK. We import the Tkinter library and give it the short name TK for convenience. Root equals TK creates the main window object of the application. This is the root for all your widgets. Root.title, my first Tkinter window, sets the text that will appear in the Windows title bar. Root.geometry, 400 by 300, defines the initial size of the window in pixels. The format is width x height. Root.main loop, this is a mandatory line. It starts Tkinter's infinite event loop, which listens for user actions, e.g. button clicks, text input, and updates the graphical interface. Without this line, the window would appear and immediately disappear. Example 2, label and button with event handler. This example will show how to add text and an interactive button. Change the label text. Step 1, create the main window. Step 2, create a label widget. A label is a widget used to display text or images. Step 3. Place the label in the window using pack. Padding equals 20 adds vertical padding. Step 4. Create a button widget. Text on the button, command, function to be called when pressed. Step 5. Place the button in the window. Step 6. Start the main event loop. Step-by-step description, def on_button_click, defines a function that will be executed when the user clicks the button. Label.config, text equals, button was clicked. Inside the on_button_click function, we use the .config method of the label widget to change its text property. This updates the text displayed on the label. Label equals tk label, root, text equals, press the button below, font sad face Arial, 14, creates a label widget. Root, specifies that the label will be inside the main root window. Text equals, dot, sets the initial text of the label. Font sad face Arial, 14 sets the font and its size. Label.pack, padding equals 20 places the label in the window. Pack is a simple layout manager that automatically packs widgets. Padding equals 20 adds 20 pixels of padding above and below the label. Button equals tk button, root, text equals, click me, command equals on_button_click, font sad face Arial, 12, creates a button widget. Command equals on_button_click, this is a very important parameter. It specifies which function will be called when this button is pressed. Note, we pass the function name without parentheses so that the function is called only on click, not immediately when the program starts. Button.pack, padding equals 10 places the button with 10 pixels of padding. Example 3, entry field and text output. Let's learn how to get input from the user. Function that takes text from the entry field and displays it in a label. Get text from the entry field. Update the label. Step 1. Create the main window. Step 2. Create an instruction label. Step 3. Create an entry widget. Entry is a single-line text field for data input. Step 4. Create a submit button. Step 5. Create a label to display the result. Step 6. Start the main event loop. Step-by-step description, def display_name, defines the function that will process the input. User underscore input equals entry underscore field dot get. The dot get method of the entry widget is used to retrieve the current text entered by the user in the field. Result underscore label dot config, text equals f, hello, user underscore input. Updates the text in result underscore label using the obtained input. Entry underscore field equals tk entry, root, width equal 30 creates an entry widget. Width equal 30, sets the width of the input field in characters. The remaining steps are similar to previous examples for creating and placing labels and buttons. Example 4, Multiline Text Field, Text. This widget allows entering or displaying multiline text. Retrieves all text from the text field. .get, 1.0, end, 1c, this is the standard way to get all text, 1.0, line 1, character 0, start of text. End 1c, end of text, -1 character, to avoid capturing an extra new line. Step 1. Create the main window. Step 2. Create a multiline text field, text. Wrap equals word for word wrapping. Insert initial text. Step 3. Create a button to retrieve the text. Step 4. Create a status label. Step 5. Start the main event loop. Step-by-step description, def get underscore text underscore content, defines the function to retrieve text. Content equals text underscore area dot get, 1.0, end, 1c. The dot get method of the text widget requires two arguments, start and end positions. 1.0 denotes the beginning of the text, first line, zeroth character. And 1c denotes the end of the text, excluding the last character, which is often an extra new line. Text underscore area equals tk text, root, height equal 10, width equal 50, wrap equals word creates a text widget. Height, number of lines. Width, number of characters wide. Wrap equals word specifies that text should wrap by word if it reaches the end of the line. Text underscore area dot insert, 1.0, comma, dot. The dot insert method is used to insert text into the field. 1.0 specifies where to insert the text, at the beginning. Example 5, Check button. Check buttons are used to select multiple options from a list. Displays the state of the check buttons. .get, for int var returns 0, false, or 1, true. Step 1. Create the main window. Step 2. Create Tkinter variables to store check button states. Int var stores an integer, 0 or 1. Step 3. Create check button widgets. Variable links the check button to a Tkinter variable. Step 4. Place the check buttons. Anchor equals W aligns to the left, west. Step 5. Create a label to display the result. Step 6. Start the main event loop. Step-by-step description, Python_var equals tk int var, for each check button. You need to create a special Tkinter variable, e.g. int var for integers. String var for strings, boolean var for boolean values. These variables automatically update when the user changes the check button state. The .get method of these variables returns their current value. Check_Python equals tk check button, root, text equals Python, variable equals Python_var, command equals show_selection creates a check button. Variable equals Python_var, links the check button to the Python_var. When the check button is checked, Python_var will become 1, when unchecked, 0, command equals show_selection. The show_selection function is called every time the check button state changes. If Python_var.get checks the state of the variable. If the check button is checked, get will return 1, which evaluates to true in a Boolean context. Hack anchor equals W, pd equals 5 anchor equals W aligns the widgets to the western, left, edge. Example 6, Radio button. Radio buttons are used to select one option from several. Get the value of the selected radio button. Step 1. Create the main window. Step 2. Create a Tkinter variable for the radio button group. All radio buttons in one group must use the same variable. Set initial value, if 1 should be selected by default. Step 3. Create radio button widgets. Variable, links the radio button to the radio_var. Value, the value that will be set in radio_var when this radio button is selected. Step 4. Place the radio buttons. Step 5. Create a label to display the result. Step 6. Start the main event loop. Step-by-step description, radio_var equals tk string var, a single string var, or int var, is needed for a group of radio buttons. This variable will store the value of the radio button that is currently selected. Radio_var.set, option a, sets the initial value of the variable, making option a selected by default. Radio_a equals tk radio button. Variable equals radio_var, value equals option a, creates a radio button. Variable equals radio_var, specifies that this radio button belongs to the group controlled by radio_var. Value equals option a, this is the value that will be set in radio_var.get, if this specific radio button is selected. Values must be unique for each radio button in the group. Command equals show_choice, the function is called when any radio button in the group is selected. Selected_option equals radio_var.get, retrieves the value of the selected radio button from the shared variable. Example 7, drop-down, option menu. Option menu allows the user to select one item from a predefined list. Called when an item is selected from the drop-down. Step 1. Create the main window. Step 2. Create a Tkinter variable to store the selected value. String var is used for string values. Step 3. Define the list of available options. Step 4. Set the default value, first item in the list. Step 5. Create the drop-down menu, option menu. Pass the main window, the variable to store the selection, and the list of options. Step 6. Create a label to display the result. Step 7. Start the main event loop. Step-by-step description. Selected option var equals tk string var, root. Creates a string var to store the selected item. Root is passed as the parent. Although it's not always strictly necessary, it's good practice. Options equals, apple, banana, orange, pear, defines a regular Python list with all available options. Selected option var dot set, options, 0, sets the first item in the list as the default value so the drop-down is not empty. Option menu equals tk option menu, root, selected option var, asterisk options, command equals on option select creates an option menu. Root, parent window. Selected option var, the variable that will store the selected value. Asterisk options. The asterisk unpacks the options list so that each item becomes a separate argument to option menu. This is the standard way to pass a list of options. Command equals on option select, the function that will be called when the selection changes. Important, this function receives the selected value as an argument. Def on option select, selection. The handler function accepts a selection argument, which is automatically passed by option menu. Example 8, Simple Calculator, using grid for layout. This example combines several widgets and demonstrates how to use the grid layout manager. Performs calculation based on entered numbers and operation. FG, text color. Step 1. Create the main window. Step 2. Create labels and entry fields for numbers. Step 3. Create a drop-down for operations. Default value. Column span equals 2 occupies 2 columns. Step 4. Create a button for calculation. Step 5. Create a label to display the result. Step 6. Start the main event loop. Step-by-step description. Try.accept value error, used to handle errors if the user enters non-numeric values into the entry fields. Number1 equals float, entry underscore number1.get. Retrieves text from the entry field and converts it to a floating point number, float. TK label, root, text equals, number1, dot grid, row equals 0, column equals 0, pads equals 5, pd equals 5, sticky equals, w. Here, the grid, layout manager is used. Row equals 0, column equals 0, places the widget in the first row, index 0, and first column, index 0, of the grid. Pads equals 5, pd equals 5, adds horizontal and vertical padding around the widget. Sticky equals, w, sticks the widget to the western, left, side of the grid cell if the cell is larger than the widget. Can be n, s, e, w, north, south, east, west, or combinations, e.g. nw. Entry underscore number1 dot grid, row equals 0, column equals 1, pads equals 5, pd equals 5. Similarly, places the entry field in the same row but the second column. Operation underscore menu dot grid, row equals 2, column equals 0, column span equals 2, pd equals 10, column span equals 2, this widget will span 2 columns in the grid, starting from column 0. Example 9, Message Boxes. Tkinter allows displaying standard dialog boxes for warnings, errors, or confirmations. Important: message box needs to be imported separately. Step 1. Create the main window. Step 2. Create buttons to call different types of message boxes. Step 3. Label to display the answer to the question. Step 4. Start the main event loop. Step-by-step description. From Tkinter import MessageBox. MessageBox is a separate module within Tkinter that needs to be explicitly imported. MessageBox.showInfo, title, message. Displays an informational dialog box with a title and message. There are also show warning and shower. Response equals MessageBox.askQuestion, question, dot. This dialog box returns a string, yes or a no, for yes, / no buttons. Other options include, ask a cancel, ask yes no, ask retry cancel. Example 10, displaying an image, using pillow. To work with images other than GIF in Tkinter, you often need the pillow, fork, library. Important, import image and image tk from pl/pillow. Step 0, make sure you have an image file, e.g., python_logo.png, in the same folder. If you don't have an image, create a simple PNG or JPG image. Or replace the path with the path to an existing image on your computer. Open the image using PL. Replace with your image file name. Resize the image if it's too big/small. Optional, but useful for fitting. Original_image.thumbnail, 250, 250, #max size 250 by 250. Convert the image from PL format to a format understood by Tkinter. Update the label to display the image. Important. Keep a reference to the image, otherwise it might be garbage collected. Step 1. Create the main window. Step 2. Create a label that will serve as a container for the image. Step 3. Create a button to load and display the image. Step 4. Create a status label. Step 5. Start the main event loop. Step-by-step description, from PL import image, image TK, to work with images other than GIF, PNG, JPG, etc., you need to install the Pillow library, pip install Pillow. Then, import image and image TK. Original_image equals image.open, python_logo.png, use image.open, from Pillow to load the image file. Make sure python_logo.png, or whatever image you use, is in the same folder as your Python script, or provide its full path. tk_image equals image tk.photoimage, original_image converts the image from Pillow's format to a format that Tkinter understands. Image_label.config, image equals tk_image sets the converted image to the label. Image_label.image equals tk_image, critically important step. Python uses garbage collection. If you don't keep a reference to the tk_image object, e.g. by binding it to the image property of the label itself, Python might delete it, and the image won't display. This is a common beginner mistake. Try.accept, added to handle potential errors, such as the image file not being found. Conclusion. Congratulations! You have just gone through 10 examples of working with Tkinter and have mastered its core components: windows, labels, buttons, entry fields, text areas, check buttons, radio buttons, drop-down menus, message boxes, and even displaying images. You also worked with two main layout managers, Pack and Grid. This provides an excellent foundation for creating your own graphical applications in Python. Keep practicing, combine widgets, experiment with different options, and create your unique projects.